Hello, my name is John Sayer, Technical Marketing Manager, Civil Infrastructure here at Autodesk. Today I would like to take you through an overview of drainage design in InfraWorks 360. The goal for today is to demonstrate some of the functionality of the drainage design vertical for InfraWorks 360 when working on a roadway project. I say some of the functionality because of the time today, we will only be able to touch on several key areas, but we will not be able to go into great detail about the functionality. But from this demonstration, I believe that you will see the business benefit of using the drainage design vertical for InfraWorks 360. So let's get started. In this overview, I'd like to focus on several key areas. The first key area I'd like to focus on is watershed analysis. The second would be culvert creation and analysis. The third being roadway inlet and pipe analysis. The fourth key feature that we will talk about today will be the updated drainage catalog and being able to pull quantities after you've created your final design inside of InfraWorks 360. We will have a brief demonstration for each key area that I discussed above, and then we'll have a summary at the end. So let's start off with watershed analysis. There's three key things I'd like to show today. One of them being point watershed creation, the second being roadway watershed creation, and then watershed analysis. So let's give you an example of each. The first example being a point watershed would be if you needed to know how much watershed was coming to a specific point in your model. Okay, it doesn't have to have a road or anything to it. It can just be a point and it'll calculate the watershed to that point. The second being roadway watersheds. We can select a roadway and it will calculate where the roadway crosses any streams, and it separates the watersheds out so that we can take the next step and add culverts to it later on. And then watershed analysis, so we can actually go in and tell it what hydrology method we'd like to use so that we can gather the correct information to get to our peak flow in CFS. So let's jump into InfraWorks 360 and show you this functionality. To start off by giving you a bit of background about this project, we've been asked to gather watershed information on a new through road that's been laid out. But first, I'd like to be able to show how much contributory area is going to a specific point in our project. So we know that our new road will start here at this road here on the east, and we're going to come through the property and tie back into a road here on the west. So we're going to have a couple of stream crossings. So I'm going to select a point, and I'm going to get a total contributory area to this point right here because this is my point of interest. So I'm going to go up and get into my drainage design module. I'm going to drop down to create watersheds and I'll hit OK. So I'm just going to select an area here. I'm going to go ahead and pick, I believe my point of interest is right here, and I'll select enter. Now what InfraWorks 360 is doing is it's going out and doing the analysis on the cloud, and it will bring back our results. We're not only going to get the watershed, but we're also going to get our streams as it's calculated in InfraWorks 360. So you can see it's a rather large contributory area. Again, this is just for preliminary, so we can kind of see what kind of area we're dealing with. We're going to get into greater detail in a moment. So now that we have an idea of our overall contributory area, we need to go ahead and look at our roadway and have InfraWorks 360 calculate our watershed for our roadway. So I'm going to change proposals here, so that we can see our roadway, how we've got it laid out and designed. I'm going to go through the same process as I did whenever I created a point watershed. So I'm going to select Create Watersheds again, select OK, and I'm going to pick my road. All right, so once I've selected my road, I want to use the entire length for it to do the analysis, so I'm just going to select Enter. And it's going to, again, go out to the cloud and do the analysis in the cloud and bring back the results into InfraWorks 360. Once the watershed information has come in from the cloud, it'll populate our model with that information. I can zoom in and I can look, and I've got a couple of places where we believe that there will be a culvert. But what we need to do first is we need to start to analyze each watershed. So you can see the different coloration of the watersheds. So this watershed would be coming to this point, and the rest of this watershed here would come to this point. Let's do this. Let's select this watershed, and let's edit that watershed. So we're going to use the rational method today. We've got a couple different ways that we can do this. We can do a user-defined method. We can use the rational method or the regression method. Today we're going to use the rational method. I'll put in my runoff coefficient, and I'll put in my rainfall intensity. So there's 167 CFS coming to this point. So I'll exit out of edit mode for that watershed, and I will select the next watershed and do the same thing. So I'm going to go ahead and select rational, put in my runoff coefficient and my rainfall intensity in inches. So very quickly we can gather watershed information for not only a point in our model, but according to how a roadway is laid out and crosses different streams. So let's go back and talk about the other key features. The next key feature I'd like to talk about today is culvert design and analysis. Inside of InfraWorks 360, the drainage design vertical will automatically place culverts along our roadway according to our watershed analysis. We can then do a detailed analysis of that culvert, and then finally we can print out a report on that culvert so we can give it to all the stakeholders so they can review the design. So let's run through a quick demo of how this works. So now that we have our watersheds defined, we can see that we've got our particular streams running across this project. So we've got a stream coming down. We will have a culvert crossing here underneath our road, and then it will merge into the main stream coming through the project, and we'll have another culvert here where it passes underneath our roadway. So what we need to do is we need to add these culverts in, and we need to throw a design on them. So I'm going to select the road. I'm going to right click, and I'm going to tell it I want to add culverts. Now, we've already defined the watershed information, meaning we've already put a design to each watershed. So the culverts come in and they've got an initial design set to them. If we want to select each culvert, we can. We'll start with the first one downstream, and you can see the asset information that it gives you. We'll particularly look at our downstream tailwater elevation and our velocity, because 15 feet per second is a little fast, so we might want to slow that down. So if we look at our asset card for that culvert, we can see it gives us a lot of information. We can see the culvert length, the entrance elevation, the exit elevation, the barrel slope, and the barrel skew angle. So if we want to drop the velocity, one way we can do it is to either change the shape. So we could actually change it to a box culvert. Okay, now you can see it's a box. Okay, and the velocity actually went up. So we've chosen that we'd like to stay with a box culvert. So we'll just add a barrel. So we'll add a second barrel, and you'll see that velocity drop. And these are just some of the considerations that you take whenever you're designing a culvert. So it dropped to 15 feet per second. We can go ahead and we can add a third barrel, and that'll drop it down even further. All right, so now we're down to 14.2. That's going to be something that we're going to be okay with for this particular time. We can change materials, and we can actually add in the Manning's End that we'd like to use. We've thrown a design at the first culvert, so let's go ahead and select that second culvert. We'll spin around here so you can see all the information. Downstream, we're at 9.2 feet per second, so we're going to go ahead and leave that circular, but we're going to add another barrel so that we can drop that velocity. So we dropped it to 7.36. That's good. You can see that it is handling the flow per barrel is 83.5 CFS. So you get a wealth of information from not only the asset card, but the assets shown here on the screen. Once we're done, we've actually laid a design for our horizontal and vertical location of our culverts, and we've thrown a design at it so that we can see that we've got sufficient flow through those culverts. So lastly, what I'd like to show here in this portion of the overview is I'd like to show that we can actually print out and generate an analysis report. So if we select Generate Analysis Report, it will create a report that shows all of the design calculations and information for that particular culvert. So if I scroll down here, you can see that you've got all the information that you would need, so you can better collaborate with stakeholders, all of the stakeholders on this project. So again, this report can be printed right here out of Internet Explorer or Google Chrome. Let's go ahead and take a look at the next key feature. The next key feature that I'd like to talk about today in the overview is roadway inlet and pipe analysis. In the drainage design vertical for InfraWorks 360, you have automated inlet and pipe placement, inlet and pipe analysis, and heuristics for inlet, manhole, and pipe design. So let's talk about automated inlet and pipe placement real quick. You're able to control this inside of the asset card as to how close you would like to have it typically add inlets. So if it's 300 feet, it will add inlets every 300 feet until it sees inside of the watershed that it needs to add an additional inlet, and then it would override that 300 feet. This number can be 300 feet, 400 feet, whatever you would like it to be. Inlet and pipe analysis, we talk more about actual design of the pipe and whether it can actually carry the flow from point A to point B, meaning from inlet to inlet. So it will accurately size the pipes so that you can get a good idea of what your design needs to be. In heuristics for inlet, manhole, and pipe design, when we're talking about that, we're talking about what you see here on the screen. It will actually give you the HGL and EGL of the pipe and additional information, as I will show inside of the demo. We're also going to be able to get the gutter spread and gutter depth from inlet to inlet, which is key whenever you're designing pipes and inlets. So let's jump over into InfraWorks 360 and show you what we're talking about. So back in our model in InfraWorks 360, we've taken into account for the drainage areas, and we've also taken into account for the culverts that are going to need to pass underneath the road to take into consideration for the streams that are existing on our project. So now I'd like to add some inlets and size the pipes to carry the flow of the road. So I'm going to zoom in here to my roadway, and I'll select my road, and I'll tell it that I want to add pavement drainage. I've got some features here I can change inside of my asset card. So I can change the type of inlet. When we look at the types of inlets that were provided, we can see that there's been additional inlets and additional structures added to InfraWorks 360. So I can scroll down here. If I'd like to select a rectangular inlet with a grate and a catch basin, I can go ahead and select that. I don't want any sump inside of my inlets. My maximum spacing, I'm going to leave that at 400 feet. Again, I talked about this earlier. We could actually change this to 300 feet or 500 feet. I'm going to leave it 4 for right now. I don't have any manholes, or I'm not going to have any manholes, so I'm going to leave this circular covered. My centerline offset, I'm going to go ahead and make that 10 feet, and I'll drop down. And we can actually change the type of pipe, so you can change how the pipe comes in and looks inside of InfraWorks 360. We'll leave that alone for right now. It's going to look like concrete. Default, all the pipe will come in 20-inch diameter. Now, this is something that we will that will change whenever we do our design on the pipes. So I'm going to leave 2/10 drop across the structures, and my material is going to be concrete. I do have several different materials I can pick from. We'll leave it concrete today. So I'll go ahead and hit enter, and it will create my pavement drainage. What can we do with these inlets now that they're in our model? Well, number one, I explained that we could do some design on the pipes because they all come in default at 20 inches. So we can select the road, right click, and size our pavement drainage. So we'll let it size our pavement drainage. So it's going to size the pipes according to how much flow is actually being captured inside of our inlets in our road. So it is taking into account for gutter flow, bypass, things of that nature, which are key design features when you're designing roadway infrastructure. So now that it's done sizing the pipes, let's just zoom in real quick. We'll look underneath the road, and I'll select one of those pipes. So if I select that particular pipe, it's sized it to a 21-inch. So it's taking into account for the flow that's coming into the inlets and getting to the pipe. So it's a collective flow for this particular network. So the pipes have been sized. The next thing I might want to do is I might want to look at some of the inlet characteristics. So if I select one of the inlets in my asset card, I can see the rim, the bottom elevation. I can see there's no sump. We told it in the beginning that we didn't want any sump. I can also see my analysis. So I can see the intensity that was used, the runoff coefficient, the designed flow that's actually coming to the inlet, and the intercepted flow. So it is taking into account for bypass whenever it's looking at inlet capture. So you can see the efficiency also. Another key feature that I'd like to point out is this blue rectangle. That is the area that it's calculating going to that inlet. And notice that this is in a fill, this road's in a fill, and from the edge of the shoulder there, everything is draining back to the road. So this is the area from inlet to inlet that it's using to calculate the amount of CFS that's going from inlet to inlet. You're seeing, if I hover here over this blue area or this grayed out area, you can see that is your gutter spread. Whenever you hover over it, it gives you the depth that it's running in the curb, and you can see the spread into the road. So you can see that you can see the amount of bypass that's coming past it. So if we look at the design flow, it's 0.37 CFS for this particular inlet. The intercepted flow is 0.31 CFS, so there's 0.06 CFS that's bypassing to the next inlet. This is a fast, efficient way to gather the data that you need to make design decisions quickly. Another option we have is we can inspect the performance of our network. So if I select Inspect Performance, I can select the pipe connector that I'd like to start with and one I'd like to end with, and it analyzes that pipe network. So what we're going to be able to see here after we do that is we're going to be able to zoom in here, and I can select this visual so we can see our HGL and our EGL. So if I keep moving down this visual, I can see that the invert changes as it goes upstream. So this is very handy if you're trying to figure out if you are surcharging out of the inlet, if the pipe is sized correctly, so on and so forth. So a very handy tool that you now have at your fingertips. The next key feature I'd like to talk about is the drainage catalog and quantities. Inside of InfraWorks 360, you have an extended library of manholes and inlets. This has been added onto from previous versions, and as you can see here in the PowerPoint slide, there are rectangular structures for inlets and there are circular structures for manholes. And we talked about this a little bit in the previous demo. We were able to actually select the specific rectangular structure for our inlets right in the asset card before we applied our inlets to the road. I'd also like to talk about the estimate of quantities. We can actually go in and select the road, and it will give us quantities for the entire road, not only for our inlets and our manholes, but it'll do it for our pipes and our culverts and our outfalls. So let's jump back into InfraWorks 360 and take a look. Back in our model, we've now gone through design for our watersheds. We've actually placed our culverts horizontally and vertically, and we've added inlets and pipes and added design to those inlets and pipes. So I'd like to take a step back. We showed earlier in a previous demo that we have new structures that have been added into the drainage design vertical for InfraWorks 360. So if I select drainage network here, I can go in and I can look at those additional structures. So you can see that there has been a lot of structures added. You'll definitely be able to take advantage of these new structures inside of your model for design purposes. The last thing I want to do here today in the overview is I want to show you that you can quickly pull quantities for everything that's here in your roadway. So that's a big thing, whether it's preliminary design or it's final design, is actually pulling those quantities so that we can see what's actually going to be needed to be built. I could go back here to Design, Review, and Engineering Drainage, and I can select Quantities. It asks me to select a design road, so I'm just going to pick that design road, and my Quantities asset card will come up. So you can see it's broken out the culverts that I had designed whenever I laid them in. It's actually counted my inlets, and it's actually got the links of all the different sizes of pipes. So remember, this is showing that it did actually do the design because everything comes in at a 20-inch diameter size whenever you just bring the inlets in when they first come in. Once you add the design, it does size them accordingly to the watersheds. So you can see that this set of quantities would be very handy whether you're doing preliminary design or final design. So now that we have our preliminary design pretty much complete, I can zoom in here and see my culverts and my pipes and everything that's on my road. And I'd like to go ahead and bring this into Civil 3D for our final design. And we'll take it a step further. We'll go ahead and import the pipes and everything into SSA. So let me show you that workflow. We'll close InfraWorks 360 and we'll open up a session in Civil 3D. So I'm going to go up to the Insert tab and I want to just attach to the InfraWorks 360 model. So I'll go ahead and attach to that model. We'll show you this, that we can actually go out here and pick the objects that we'd like to bring in. So we could leave all of this checked. I'll go ahead and check everything here so that it brings everything so you can see that. And I'll hit OK. And I'll go ahead and hit Open Model. Now what it's going to do is it's going out and it's opening the InfraWorks 360 model. It's pulling in all of the information that you just saw there in that XML file, and it'll populate the drawing in Civil 3D. So we'll be able to take that information that we just created, a preliminary design inside of InfraWorks 360, and we can start to add our final design to it. So now that the information is inside Civil 3D, I'll show you real quick kind of some of the things that are brought in. We've got our line that represents our drainage areas or our watersheds. We've got our inlets and our piping that was represented inside of InfraWorks 360. And I said we were going to take it a step further for design. We could actually start to build sheets and things of that nature here in Civil 3D. I'm going to show you real quick how we can bring this into SSA and do final design on our pipes. So I can select one of my structures that's inside of my pipe network, and I'll select Edit and Storm and Sanitary Analysis and just select OK. It's going to populate the model inside of SSA with the information from Civil 3D. So once the information's been brought into SSA, we can select the Plan View tab at the top, and we can zoom in and we can take a look at what it's brought in. And you'll see that it's brought all of our structures and our pipes in from Civil 3D. Now they should definitely look familiar because this is the exact layout that we had from InfraWorks 360. So we can throw our design on here and then bring it back into Civil 3D to populate our plan and profiles. If I select one of the junction structures here, you can see that the information from InfraWorks 360 and from Civil 3D has been populated. So in summary, Autodesk Drainage Design for InfraWorks 360 is a set of specialized tools for drainage design that can help improve effectiveness and efficiency when analyzing watersheds and automating culvert design and the layout of pavement drainage. We reviewed a subset of capabilities today that includes watershed analysis, culvert creation and analysis, roadway inlet and pipe analysis, and improvements to the drainage catalog, and quantities, how to pull quantities after you've got all of your placement done. With that being said, let's understand the business benefit. When using the drainage design vertical with InfraWorks 360, I think that you can see that it's easy, intuitive, and powerful. You can definitely speed up your conceptual design process for your culverts and your inlets and your pipes inside of your roadway. You can more quickly evaluate alternatives. You also definitely benefit from the realistic visualization. And let's not forget about those quantities. So I thank you for taking the time today to watch this overview video, and I hope that this has inspired you to use InfraWorks 360 and the drainage design vertical. Thank you.